So the basic point is I did a lot of quantitative analysis, and I'm going to give you a quick overview of that analysis right now, but it's actually not really the topic of my presentation. So first of all, I felt obligated to redefine the cloud, and yesterday we heard it's all about elasticity, elasticity, elasticity. I think actually that you can define a cloud a little bit more broadly and impactfully than that. Even though I would agree that elasticity is helpful. So there's in the US definition called the NIST version 15 definition, which is pretty widely accepted, but it's a little bit lengthy, and so this is an easier one. First of all, it's common in the sense that there are pooled resources that are shared across a variety of workloads. Now, that is not elasticity per se, but it has some benefits, and the benefits are characterized by the fact that you can otherwise have overcapacity or undercapacity, and you can define a penalty function, and the reduction in the cost associated with the penalties of the wrong capacity turns out to be characterized by 1 over the square root of m, where m is the number of independent workloads. So of course, if they're correlated, you don't get a reduction in the penalty function, but if they're uncorrelated and independent, then you get a reduction that's commensurate with that. So that's statistical muxing benefits. The second attribute I would claim of the cloud is that it's location independent. In other words, unlike an enterprise data center, which you know where it is, as long as the cloud service meets the response time objectives of the application, the actual location doesn't matter. So it turns out there that meeting response time objectives is the challenge, and there's a semi-complex relationship between the number of content delivery or edge application delivery service nodes and latency reduction, which also, for different reasons, is an inverse square root function. And on a sphere, such as the planet Earth, there's actually a subtly complex adjustment that needs to be made with that double angle trig formula that's handy. But it turns out you can look at trade-offs then between investments in additional capacity. I wrote a white paper that kind of addresses the math there between using your resources in a single location to speed things up through parallelization, where you get a 1 over n type of benefit, versus dispersion, where you get the 1 over square root of n benefit, and there's a 2/3 root where the minimum is given any given application characteristic. The third thing, as Pascal Vicablanc addressed, is that the network is key to the cloud, and there are a couple of interesting numbers that I worked out, one of which is trade-offs between latency and capital investment in point-to-point networks versus in hub networks, and of course somewhere between those two is the typical mesh. Another useful analysis that you may want to look up is I use the theory of order statistics to show the benefit from doing joint optimization in multicast architectures between either server-based load balancing or network congestion-based load balancing, which is some work that Nikhil Handegol and Nick McEwen at Stanford did on SDN. They just looked at using the network, and I found exactly what the benefit is. Again, uses order statistics for the triangular distribution to determine the optimum approach, which is, of course, taking both things into account, both network congestion and server load balancing. Fourth major benefit of the cloud is pay-per-use pricing, which in telecom we used to call linear tariffs or measured service, but that turns out to be a very key benefit, and it partly depends, the magnitude of that benefit, on the workload characteristics. If you have a completely flat workload, then a private cloud can make sense. On the other hand, if you have any variability, you can show with a nifty bit of calculus that you must use the public cloud no matter how overpriced it is. And let me say that again, I don't believe that public cloud has a lower unit cost than private cloud for well-run entities. And there's this theory out there that somehow the public cloud derives immense economies of scale that therefore makes it cheaper than anyone else could possibly do. And that ignores several facts, one of which is that that's not the case, and secondly, that service providers are commercial entities that have additional cost structure elements such as sales, general, and administrative costs, cost of uncollectibles, and the need to return a reasonable profit. So not only can you show, though, that even if the cloud is more expensive, that you should still use it, but also you can show that hybrid architectures are cost optimal, and the degree to which you should be in private cloud versus public cloud depends on the peak to average ratio. The fifth element of the cloud, I would claim, is on-demand resources, which encodes both elasticity and virtualization. So the point would be that you want the resource curve to exactly match the workload demand curve, and with a less than epsilon difference between the two, which requires both responsiveness in provisioning, aka elasticity, as well as granularity of provisioning, aka virtualization, or using containers / Docker as an example. So that on-demand notion, then, though the benefit depends on the nature of the demand curve. If the demand is completely flat, then immediate instantaneous provisioning has no benefit. At the other extreme, if the demand grows to be exponential, then it turns out that any fixed provisioning interval, no matter how short, leads you to an exponential difference between the degree of the resource requirements and the resources that have been provisioned. And so that's sort of a worst case scenario. In the real world, think about Netflix when it was growing exponentially. The point is that whether it takes you 2 years to provision a data center or even 6 hours to provision a server, that penalty grows exponentially as your demand grows exponentially. There are some other things that I've looked at that aren't on this list, but the characteristics, common location independent online utility on demand. You may not be mostly native English speakers, but actually that CLOUD does spell out a handy word, so cloud is both a concept and an acronym with my definition. I've also looked at some other things that are interesting that we don't have time for, one of which is showing the value of cloud markets, which also uses some insights from the theory of order statistics to show that you don't need many players in a cloud market to provide benefit to customers. And some other things. My 20th patent was just issued a couple of months ago, and it's for a radically different approach to homomorphic encryption using random paths, but all that stuff is beyond the topic that I'm going to cover, so I'm going to skip that. For those of you that don't think this analysis is quantitative enough, I also wrote a paper called Axiomatic Cloud Theory that uses metric spaces to characterize geodispersion, measure spaces to model time, and a variety of other things like function spaces to model assorted tariffs, including linear tariffs for pay-per-use. And so you can actually take sort of concepts, sort of like if you blend Turing machines with PetriNet models and think about all of that in a distributed context. This is a completely rigorous axiomatic definition that you can then use to derive a lot of the equations that I showed you earlier. Now, if I haven't put you to sleep yet, that is all fascinating stuff, perhaps. But in a way, it misses the main point of cloud, as I realized when I was writing my book. Because really the question we should be asking about cloud and about IT generally is, does any of this stuff actually matter whatsoever? For those of you that are finalists in the competition, basically a consistent question that the judges on the jury were asking is, what is the business value? It's nice that you have a nifty technology, but what exactly is the meaning of it to customers? Now, there's a guy named Nick Carr, who you may know, who wrote a series of books, one of which is The Big Switch. which I believe is incorrect, but it's a brilliantly written and well-articulated argument. Another thing that he wrote is he wrote a book called Does IT Matter? If you don't have time to read it, the Cliff Notes version of it is no. And he actually wrote a Harvard Business Review article a few months earlier that was a little bit more to the point. It just says IT doesn't matter. His argument was IT has become ubiquitous. Anything that's ubiquitous is a commodity. Anything that's a commodity is non-strategic, and the only correct approach for non-strategic elements of a firm's cost structure is to minimize spend. Does IT Matter and IT Doesn't Matter are both extremely well-written books, or books and papers. I don't really like his argument because, among other things, if his argument is correct, then all of us in our room are wasting our time, right? We're basically doing something that actually makes no difference to anyone in the grand scheme of things. We are the number 2 sweet corn, the West Texas Intermediate crude, the frozen orange juice futures of technology. The fact that I don't like his argument, of course, is not an argument for him being wrong. But he is wrong, and the argument is wrong, and I'm going to explain why. First of all, if IT doesn't matter, and by the way, all it takes is one counterexample to prove an argument wrong, right? That's Karl Popper and falsification. If he's right, then Google can't possibly have a market capitalization of several hundred billion US dollars with extremely fat margins. If he's right, then Borders would still be in business. And if he's right, Encyclopedia Britannica would still be publishing a print edition. And Blockbuster, which is a video rental firm, would still be around. And of course they're not, because IT does matter. Google had no other advantages. It didn't have first mover advantage. It wasn't the number 17 search provider after Alta Vista and so forth. It had no preferential access to resources. It was just indexing the web, which anyone could do, and that was a publicly available source of information. It had no brand, because if brand were important in your choice of search engines, then we'd all be using the Coca-Cola search engine. And so the only thing that actually matters is IT. Besides that qualitative argument, there's data from Eric Brynjolfsson at MIT. He basically showed a direct correlation that's statistically significant between the use of big data for decision making and the usual financial metrics like return on equity. There's data from Sunil Mithas at the University of Maryland that showed a 1.91 to 1 return on investments in IT. Interestingly enough, that return is higher than R&D or marketing. That return is all on the revenue side, or virtually all on the revenue side, not on the cost reduction side. So I leveraged some of that data when I wrote Cloudonomics, but the question that one needs to ask is, it's nice to know that firms overall generally statistically gain a benefit, just like it's nice to know that people's standard of living is increasing. But what's even better than aggregate average results is results for you yourself, right? I don't care that the world is getting richer or healthier as much as I care, to be frank with you, that I am getting richer or healthier. And as a firm, we shouldn't really care that IT generally derives advantage. What we care about is, how do we derive advantage? So my next book, which will be out at the end of this year, is called Digital Disciplines. And the thesis of the book is, first of all, that IT is beneficial, it is strategic, or can be strategic, and moreover, that there are repeatable best practices that anyone can apply to leverage IT and exploit it for strategic competitive advantage. Now, all that said, I think to go back to Carr for a second, there's really a range of IT value. There is non-strategic, mundane IT that's not very exciting, that's used for ordering paper clips, that's used for reserving conference rooms, it's used for expense reporting. It's hard to believe any company saying, the way we became dominant in our market is through a better conference room reservation system. But at the other extreme, we have strategic systems that are closely aligned with the fundamental strategy of the company, what I would consider existential systems, which are those systems that are life or death issues for companies. Borders Books is a great example. Borders was one of the top 2 booksellers, if not in the world, then certainly in the US. They had all the prime real estate, customer relationships, publisher relationships, and so forth. Boy, I'm so jet-lagged, I'm hearing little beeps occasionally. It's funny. Yet they're now bankrupt because Amazon.com had a better strategy to leverage IT for e-commerce and to leverage IT to create e-readers, which therefore basically killed the equivalent, the Kobo, although I guess it may now have a second life. So what I argue is that there are 3 digital disciplines, and the reason I came up with that term is that there's a great book that was written by Michael Tracy and Fred Wiersema 20 years ago called The Discipline of Market Leaders, and they argue that there are 3 main value disciplines that companies can use. Operational excellence, in other words, better processes. Product leadership, in other words, better products or services. Customer intimacy, in other words, better customer relationships. You should read their book because it's a great book and it's still full of insight 20 years later. And basically, to give you some explanation of what they mean by all this, you can have really lousy processes. You can have really lousy products. But if you've got really tight customer relationships, your customers will overlook all that other stuff. Conversely, you could have the same sales approach as everyone else in the industry. You could be selling Me Too products that don't matter, but if you can have a cost advantage or a time advantage, then you can succeed and be able to gain market share. So they have a great model, but 20 years have passed since the book was written. So to just say, yeah, it's the same old way of better processes, better products, or better relationships, obviously doesn't make any sense. So at a high level, everything they're doing is correct, and everything they're saying will probably be true for eternity. But I think that there are 3 main new things here. First of all is this notion of what I call information excellence. In other words, leveraging digital technologies to enhance operations and achieve sort of digitally enabled operational excellence. A second area is what I call solution leadership, which I will explain, but the idea is leveraging information technology to create better products. But it's much more complex than just saying digital products. It's really about end-to-end solutions that include the product, the network, and cloud services, both in and of themselves and as a gateway to enabling APIs, partner ecosystems, and links to things like social networking. The third major, I think, enhancement that leverages today's newer technologies is moving away from pure customer intimacy into what I call collective intimacy. And you'll have to wait just a few seconds for me to explain what I mean by that. Besides their 3 general categories, I posit that there is a 4th major capability by which firms can compete, which I call accelerated innovation. And the basic idea is that if you can improve your processes, improve your products, or improve your relationships faster than anybody else, then you can gain advantage. And accelerated innovation also requires the cloud, generally speaking, to work, and I'll explain how in a second. So cloud, big data, social, mobile, Internet of Things, drones, robots, quantum computing, neuromorphic computing, fully homomorphic encryption, all of those technologies together can be brought to bear, not so much because they're cool technologies, but to address one of these four generic strategies or digital disciplines. To understand the differences, I'm going to use something that has nothing to do with IT, namely sneakers. So here are four sneakers, or athletic shoes as the industry calls them. These are four completely different sneakers. And when I said they had nothing to do with IT, I actually lied. The Nike Zoom Kobe Venomenon 4 whatever, which is a pretty long name, but clever. It's got Kobe Bryant, basketball star, Venomenon, which is like Venom and Phenomenon. It's the fourth version, so they've ironed out all the bugs. It's got super cool technology in it. It's got traction control, a special compound that works great on special rubber, wet surfaces like wet basketball courts. But it's really just a sneaker. Okay? This is the Flyknit. Let me explain the Flyknit. For the last century, sneakers have been made exactly the same way. You cut and stitch sneakers. You cut it into 40 or so different pieces of cotton, rubber, lacing, grommets, whatever, and then you assemble them. And because assembly is the main cost of the sneaker, you assemble it offshore. What Nike did is they reverse engineered a weaving machine and created a two-part sneaker, one of which is woven, the upper, and the other part is the traditional molded rubber, plastic, whatever compound. It requires information technology for the software that drives the weaving machine, and required some innovation to be able to even create this radically new sneaker concept, including reverse engineering the machine. So it's a little bit of a better product, it's lighter and better, but what it really is an example of operational excellence driven by IT. The next sneaker is the Hyperdunk Plus. This looks like a sneaker, but it's not. It's got 3 pressure sensors in it. Those pressure sensors link across a network to deliver both Nike fuel points and a lot of detailed data on every single pressure change in the shoe. So if you're sprinting sideways doing basketball or jumping, you can get data on your G-force, the height of your jump, and you can actually take a video, or somebody can take a video of you playing basketball. It's probably hard to take a selfie while you're dribbling. I guess you could do it. And then link every jump, every move to the data collected from this. You can see that for this dunk, you actually jumped 3.7 feet. Also IT, but it's really an example of a solution because it's not just the sneaker, it's the sneaker plus the network plus the cloud plus big data. This is the JW Special. If you haven't heard of any basketball players named JW, it's because JW is my initials. I designed the sneaker online, so it's an example of personalization that is mediated by IT. So 4 sneakers, different strategies around operational excellence, product leadership, aka solution leadership, and a higher degree of customer intimacy. Of course, these approaches are not just about sneakers. These are generic strategies that apply in any business. So just to give you some quick examples, this is a port, tens of thousands of containers, dozens if not hundreds of ships arriving and leaving every day, hundreds if not thousands of trucks dropping off and picking up containers every day. It's an NP hard problem trying to optimize these operations, right? You're stacking containers, you're trying to maximize throughput, and you've got even, it's not just NP hard, there is no single best solution because it depends on what you're trying to do. I personally do not want the job of optimizing this port. It obviously requires IT, and therefore ports can compete on efficiency, and that efficiency inherently is based in IT. Another good example is wind turbine farms, which also, it's not just a matter of you put these there and they generate electricity. There's so much IT now behind these things, including which way the turbine is facing, the fact that the turbines are learning from each other, the fact that there need to be linkages on the demand side and on the utility side. And so this becomes another operational excellence problem around utility electricity generation that requires sophisticated technology, including linking to the cloud for global optimization. To give you an example of product leadership, the Model T car was kind of the first product, but that's changed to solution leadership, because today's car is not just a better car with faster performance and with better windshield wipers and with better fuel consumption. It's just another entity that is part of a connected network. So today's cars, of course, have 70 or more microprocessors. They connect to the cloud for concierge services, for navigation services, for entertainment, for vehicle detection, for real-time traffic updates, and so forth. And actually, they even connect to social networks. So your car actually will connect to Twitter and Facebook. Jet engines, for example, the GE Gen X jet engine. 20 sensors on board measuring things like fuel pressure, fuel flow, oil flow, rotation speed, vibration, and so forth. And what all of those do is they generate thousands of data points per second. So 20 sensors times thousands of data points per second times an average multi-hour flight leads you to massive data being collected. That data is collected, analyzed by engineers, analyzed by collaboratively with the airplane manufacturers and the airline service operators, unless there's a strike going on, in which case there's not much data collected. But the point is that this is not just a better engine with better turbine blades, it's heavily digitalized, and that technology and data, again, links to higher level services. Soccer ball is another example, since the World Cup is on. There are soccer balls now that have these same type of accelerometers within them, and they're useful for training, right? Which leads you to some notions about, there's a couple of frameworks that are relevant. One of which is this model of the different elements of product strategy, and sort of building from the bottom up. You have, for any product, the generic benefit, right? For a sneaker, it's cushioning and maybe foot protection. For a drill, it's getting a hole. From that generic product, you have the expected product, which is pretty much what everyone now expects is in that product, right? So, for example, for a toaster, it's that it's electrical rather than fire-powered. Then you have the ability to augment that product to differentiate it in the marketplace. And one very subtle thing that really was conceptual for several decades is the notion of the potential product, which is you're not just buying a product for what it is now, but for it may be someday. Now, at the lower levels, these things are kind of pretty straightforward, right? It's just basic benefits and features. When we get into augmentation, that really requires digital technologies. And when we get to that highest layer, there are several ways in which these products are now feasible and differentiated. And the point is that you're buying a product not just now, but for what it can be, thanks to digital technologies. An example is an iPad. It's not just a single device that you buy out of the box. The application ecosystem makes it extensible and expandable. Upgrades are another example. I've got the phrase playerization. I can't see if Ash is in the room, but that's a new I don't know what the form is called, but it's a verb nominalization or something like that. But the point is the notion of being able to rapidly deliver micro updates into a device. I believe that's the first use globally of the term playerization. Adaptability through machine learning and AI. A good example of that is the Nest thermostat or drop cam, right, which learns behaviors and activities and tunes its own performance accordingly. So the ability to augment products is a mix both of the fact that they have these digital capabilities and the fact that a lot of the digital capabilities are resident in the cloud. But beyond that, this notion of solution leadership includes these other elements like the partner ecosystem, APIs, and developer communities and so forth. Customer intimacy used to mean two different things. In the consumer space, customer intimacy was like a tailor, right? There was your dress or your suit, and they would go ahead and adapt it just for you, developing a custom, personalized solution that made sense, but it was very individual. In a business context, you had businesses with dedicated account teams that understood your corporate strategy, worked with you to customize solutions. That was an organizational and or individual approach rather than a scalable information technology-based approach. So we've gone from customer intimacy to a range of additional things that both is more scalable and more intimate. Personalization is one example, but personalization to me can be very cheap, right? A mass email that says, "Dear Joe," and spells my name wrong, "here's a special offer just for you," which is the same 10% offer that everyone is getting, is personalized, but doesn't really have much personalization value to me. Customer intimacy does have value because the idea is I've got a tight relationship that engenders customer loyalty, but moreover gives me things that are beneficial to just me. But we've moved beyond mere customer intimacy by leveraging IT for scalability into what I call collective intimacy. And in case you're wondering what I mean by that, a good example is the Netflix Cinematch algorithm. So the idea is by taking data from each of you, where each of you is millions or tens of millions of customers and tens of millions or hundreds of millions of data points, and running big data algorithms around it, like we heard in the talk yesterday on personalization, I can now achieve real business benefit in terms of greater customer stickiness. But it's no longer an organizational or individual approach. It's obviously an information technology approach to being able to bond better for customers, increase customer lifetime value, reduce churn, maximize revenues and profitability. It isn't just entertainment. A lot of the things we're hearing now around bioinformatics and genomics basically have the notion of also being recommendation engines, but what they're recommending is patient-specific therapies. So because I can get a biopsy from you right now, and I can then feed that back. I see two, I know you're very gentle, I'll get off in 1 minute. The point is that I can then leverage big data for the service of more intimate relationships and better solutions / recommendations. The last piece is accelerated innovation through cloud-mediated challenges, and so here I think there are several major elements, one of which is moving away from purely internal innovation with salaried employees to external innovation or open innovation, and rather than just merely structuring it by paying someone like an outside consultant, it's moving to contest economics or challenges, and things like the Netflix challenge, GE Hospital Quest, or Flight Quest are good examples of doing that. Again, this is something that is very hard to picture at scale without the cloud, because now that gives you both scale for global reach as well as time compression by instantly publicizing that and being able to get the data sets out as well as the results back. So speaking of accelerated innovation, how's this for a segue? I am done, and I think we'll move into the open contest challenge, contest economics as a way of supporting innovation. So that's it. Thank you.
So we have time for one question, if there is any.
Joe, how did you use collective intimacy? Thank you. Joe, how did you use collective intimacy in your company to gain new customers? Because the way I understand it is a way of improving a service to existing customers. Perhaps I didn't understand it well because it was... but I would like to know how you can use this to gain new customers.
Yeah, that's a very good question, and I would say that from a strategic perspective, none of these things per se are oriented to gaining new customers directly. They're all really oriented towards differentiating yourself so that when any customer is selecting a service provider or a product vendor, they will pick you because you're better. And that better can be better processes, better products, or better relationships. And then there are the indirect benefits as a result, which is, you've got word of mouth, you've got positive market share trends, you've got less bad word of mouth. I don't know if you've ever seen the United Breaks Guitars video, but someone broke the guitar, and you're delivering better targeted outcomes that then feed into that. So for example, if there's two hospitals and one actually has better health outcomes because they're leveraging more big data to target a therapy to me based on both my exact current condition as well as the genomic analysis and personalization optimization type of effects, then I'm going to go to them, right? Because I know that my friend got cured and my other friend passed away, so it's a matter of then differentiation, and then that differentiation provides the basis for, I would say, the usual customer outreach mechanisms, right? So if I've got, the best SLAs in the business, I can deliver faster, more accurately, whatever. That then forms the basis to be able to advertise my wares or services with objective data. So, but it's a great question. All right, one more question or out of time?
Any other quick question? There is.
Okay. No, I won't sell you the trademark for playerization.
You ruined my question. For camera, can you just repeat what a playerization is?
See, that's keys of marketing it. So playerization is a new technology that involves streaming micro fragments of code for immediate updates to enhance product extensibility.
Thank you very much.
Okay.